So welcome. Welcome to this PhD defense of Daniele Di Mitri. You can all sit down. So I'd like to welcome you here at your defense. I also like to welcome the members of the Doctorate committee, and you see them all on the screen. You see Professor Hoppe here down in the line, Professor Klamma right above from Technical University of Aachen, Professor Hendricks from Vrije Universiteit Amsterdam, where is he? Over there to the right, Professor Kaltz from the Open University and from Heidelberg University in the middle, and Dr. Brumori from the Open University on the right. I also like to welcome the supervising committee here in the room and also on the screen. And I especially like to welcome Daniele Di Mitri. I wish you good luck, and I hope that you enjoy the opportunity to discuss your thesis with the opponents. But for now, I invite you to give us a brief summary of your PhD thesis.
Dear guests, dear colleagues, cara familia, good afternoon and welcome to the final presentation of my PhD project, the Multimodal Tutor, adaptive feedback from multimodal experiences. How do people learn nowadays? In times of COVID-19 pandemics, the first thing that comes into our mind are video conferencing tools. Also, what we think at is online learning. Well, if this is true for most of the academic learning at this point, there are certain other learning activities that require physical interaction. I'm thinking, for example, about learning how to play a new sport or learning how to cook a new recipe. All these activities require a certain level of interaction with physical objects. In my PhD journey, I focus on these learning activities, and I investigate how computer algorithms and data can support these learning activities. I look into the field of multimodal learning analytics, MMLA for short. The researchers in this field start from the assumption that there are new technology devices, such as the mixed reality glasses, or smartphone sensors, or smartwatches, or other devices, wireless devices. And these new technology devices, they can collect data that go beyond the keyboard and mouse. This data from multimodal and multi-sensor interfaces, combined with the learning analytics approach, which is defined as the measurement and the collection of data about the learners, results into a more accurate representation of the learning process. In my PhD journey, I like it to compare it to a maritime journey of expedition, which is composed in 4 parts. The first part is the Exploratory Mission, in which I conducted the Learning Pulse study. The second part is the map of multimodality, in which I conducted a literature review and developed a conceptual model and defined 5 big challenges of multimodality for learning. The third part is the preparation of the Navy, so the technological infrastructure that supports this challenge. Here, the visual inspection tool, the Multimodal Pipeline, were developed. Finally, the Conquest mission, which is the development of a real-time feedback system for Cardiopulmonary Resuscitation, CPR for short. I will go now explore these studies one by one. The first one is Learning Pulse, in which we gathered 9 participants all them wearing a Fitbit devices, from which we collected heart rate and step count activities. And we combined that with activities or softwares they were using on their laptop. Combined that with also meteorological data on the context where they were working. We also asked the participants to self-report each hour of their work, their self-perceived level of stress, productivity, challenge, and abilities. Challenge and abilities are two concepts which make the concept of flow, which is a psychological construct that measures the level of engagement with a certain task. So we got a lot of interesting insights from this experiment, especially we got to know how difficult it is to combine data from different sources. And also that it's possible to actually predict certain educational performance from multimodal data. We dig deeper in the concept of multimodal data in the second study, where we explored literature in this area. We were interested to see what other modalities people were used in the related studies. And we found out that many studies had to do with motoric behavior of the learner, but also some others mapped the physiological measurements, such as the heart activity or the brain activity. In addition, also the context of learning is quite relevant, quite important. That led to the formulation of this concept. The data that we can capture for the modalities from the sensors can capture the behavior and the context of learning. What the sensors cannot directly measure are dimensions, unobservable dimensions that stand below the observability line. We are thinking, for example, about emotions, motivation, cognition, and beliefs. The idea of the observability line was brought again into the Multimodal Learning Analytics Model, a model that shows how to collect sensor data and multimodal data and use human annotation, combine them with machine learning, and generate prediction that can foster feedback and trigger some behavioral change. This model was the base for our scientific investigation. We went further and defined the 5 challenges. What we noticed in the related literature is that multimodal data is rather messy, and most of the related studies, they stand only to the level what we call the data geology. So they investigate predictability of certain factors towards educational performance. We found out that there is no clear and coherent picture of how multimodal learning analytics can support learning. And therefore, we identified 5 big challenges for closing what we call the multimodal feedback loop. Those are the data collection, the data storing, the data processing, the data annotation, and the data exploitation. We also envisioned some solutions for these challenges. For the data collection challenges, together with my colleague Jan Schneider, we developed the Multi-Modal Learning Hub, which is a tool that gathers data from multiple sensor applications and synchronize this data into a coherent data format that can be later reused. We also developed a tool for the data annotation. That's the visual inspection tool that allows the researcher to load multimodal data recordings, to visualize them in video, but also plot the sensor values, and also they can annotate certain time intervals, assigning multiple annotations. These annotations will be later used for machine learning. All these tools fall into a technological framework, the multimodal pipeline, which is a framework composed by generic solutions for the 5 big challenges. The aim of the pipeline is to support researchers in setting up experiments much more quickly and also to reduce their data manipulation overhead, and so they can focus on the data analysis. We use these constructs and frameworks, and we apply them into the domain of cardiopulmonary resuscitation. Why did we choose for CPR? CPR is a task which is taught singularly to each learner. It's a highly standardized procedure. It has a clear and defined criteria to measure the quality, and it's also a relevant skill that everyone should learn. We focused on some particular mistakes in CPR. Those are the compression rate, compression depth, and compression release that are typically tracked by standard CPR tools like the Resusci and mannequin. But we extended also the mistake detection to other typical mistakes like not correct position of the arms and also not correct locking of the elbows. These mistakes are not tracked by the standard CPR mannequins. And we finally designed and developed the CPR Tutor in 2 iterations. In the first phase, we created a hardware setup consisting of a Microsoft Kinect, which is a depth camera, a Myo armband, and a LiDAR Resusci and mannequin. And we collected roughly 5,000 chest compressions from 14 experts. And we tagged each chest compression with the 5 mistakes. Later, we trained 5 neural networks to classify the CPR mistakes. In the second iteration, we focused on the CPR feedback. The CPR tutor is supposed to give audio feedback to the person performing CPR, such as, for example, lock your arms or use your body weight. We used a real-time feedback architecture composed by Microsoft Kinect, Myo armband, that uses 2 components, the CPR tutor collecting data from the sensor devices, and the SharpFlow component that classify each chest compression using the previously learned machine learning models and providing feedback in real time. What we found out is that directly after each time that the feedback was fired, there's a decrease of the error rate. That's showing that the feedback has certain kind of effect. To that, we can draw some conclusions to our project. The first one is that sensors cannot directly reason about the data they collect. And therefore, machine learning and human annotation can help for automatic reasoning. The second one is that multimodal tutors can support the learners when the human instructor is not available. The third one is that multimodal tutors can help closing the feedback loop using multimodal learning analytics. Finally, the multimodal tutor is an example that paves the way towards better human-AI cooperation. Thank you very much for your attention.
Okay, thank you for your presentation. You can close down now your presentation. Please keep the conversation tool open.
Yes.
Yes. Okay. If you're ready, we will start the opposition. And I give the word to Professor Hoppe from University of Duisburg, Essen. Your mic is, you have to put on your mic.
Now it should work?
Yes, okay.
Thank you very much. Thank you very much also for giving me the opportunity to be here in this defense. First of all, I was really impressed and enjoyed reading your thesis. Very nice work, very timely, to me in my own research and interests. So when I was reading through the thesis, I was kind of asking again and again one question to myself, and it grew, was you make certain general claims from the very beginning about multimodal learning analytics and connecting it also to the learning environment in the exploitation phase, as you named it. And the examples that we see are primarily examples that have to do with psychomotor tasks and skills. Later in your discussion of limitations, you indeed take that up. Yeah? So also much appreciated. You take it up, you discuss it. You say there's still a lot to do if we move towards cognitive, or I would also say more complex task environments. You mentioned social interactions also. I would still raise the question to you if you could elaborate more concretely on the steps towards this wider application of multimodal learning analytics, including cognitive tasks, complex environments. I have seen visions and partly also implemented of classroom tracking systems, yeah, from China. I don't mean Lumilo. You mentioned Ken Molstein's Lumilo system. You may elaborate on the differences here. This is not such a classroom tracking system. What is your feeling about the possibility of general classroom tracking? And if there is a practical possibility, how could it be used and should it be used?
Highly learned opponent. Thank you very much for the interesting question. If I understood correctly, you're interested to know how the solution that I envision, the multimodal tutor, can generalize to more cognitive and complex skills, primarily those that happen in the classroom. And indeed, as you said, in my PhD project, I focus more on psychomotor tasks. And I also explained that the multimodal interaction principle allows to track motoric action better than cognitive, the cognitive abilities. So that, for me, was a starting point to first look at what is mostly visible by the sensors. I think that with the iceberg metaphor, I somehow show how we can infer these sort of hidden dimensions using behavioral cues, such as, for example, head movements or physiological responses and so on. So I can imagine that in the future, the multimodal tutor can develop to more complex tasks that are definitely less structured than CPR, so more open-ended, for example, and that require a certain level of cognition and coordination of thoughts, of attitudes, of beliefs, and so on. The Lumilo example is one taking place in the classroom, identifying students at risk and raising virtual hands whenever these students are struggling with certain tasks. With my colleague Jan Schneider, we are also working to solution the classroom of the future, where we actually plan to connect ambient sensors in the classroom and track the behavior of the students in terms of physical behavior, movements, and so on, and relate that to some sort of learning tasks that they are doing. So I believe that the complex and cognitive learning, it is, in the future, it will be possible to analyze with this multimodal tutor system. However, it's important to define, to have a clear definition of what is the learning task. So the learning task definition, it's highly important. And that's one of the learned lesson also from the first experiment that we did, where we didn't actually define clearly what the participants were doing, and we found out that that's not really the way to go. So clearly well-defined also cognitive learning task, and can allow to have a multimodal learning analytics approach. And we were confident that would lead towards a better understanding and better insights in how the people are learning.
Professor Hopper?
Okay, thank you for the answer. I think you took up my question very well. I would like to raise, if there is time, 2 follow-up questions. One, regarding the Lumilo example. I mean, I would not characterize it as an example of multimodal learning analytics or a learning environment that is based on multimodal learning analytics. How do you see that? Maybe you see it differently. Brief, hopefully this could be very brief. And the second follow-up question...
the second question, I think we have to leave it for the second round. But the short answer to that...
Then I leave this as a comment, and the question is indeed related to the pulse environment with this concept of flow that you have been focusing on. I like that very much. I have discussed a lot about flow, and I had my own flow experiences, hopefully. You measured it using ability and challenge. And that was based on self-report. So I was asking myself, of course, you took all the sensory data, but I did not really see how the sensory data were related to these self-reporting data regarding flow. And particularly for flow, you would expect certain, say, physical states of arousal, etc. Have you thought of that? And did I miss something maybe when reading the paper?
If I understood correctly, you want to know how I operationalize the concept of flow in the learning pulse experiment.
Yeah, I know the formula. I've seen the formula. It uses ability and challenge, I think, and this is based on self-report. So in how far is it related to sensory data?
The self-report, indeed, it's the concept of flow, as you said, is related to the self-report. We actually trained a model that uses the self-reports as labels. And so we are actually trying with mixed effect linear regression to predict the levels, to predict what are the future values that people are going to self-report. So that's kind of the relation. So we are trying, with the data that we have available, we are trying to discover some relationships between the self-reports of the flow. And
this is what one would expect. Have you done that, or have you have results on that?
We did that, and the results are reported in the results section of the first experiment with the results of the mixed linear effect model. And so those are the results to the extent to which our model is able to predict the values of challenge and abilities. And the level of flow, it's basically a combination of challenge and abilities.
Okay, and I think we have to end up
so this is more or less, I agree with you that this is one way to calculate the flow. There are more complex, I would say, questionnaires to be able to survey and assess the flow. But that's the way we chose.
Okay, for further discussion,
yes.
I think. Then I give the floor to Professor Klammer from Technical University of Aachen.
Yeah, thank you very much. I want to thank for the invitation to this committee and the opportunity to read and comment on this nice work by the esteemed candidate. Thank you very much. So my first question is concerning the quality of sensor signals. I think you have already addressed that in the section on limitations of your thesis work, and there's a lot of criticism coming from people from pedagogy or psychology about using sensors in research, in motor psychic studies and so on. And this has to do with the application of sensors, particularly if they are body-worn. Yeah? So one criticism is that they claim that little errors or differences in the application of sensors on the body, within the body, lead to totally different results in the sensor signal. And it would make it very difficult impossible to compare signals from different participants in experimental studies. Is that experience you already had in your thesis and addressed that? Is that something you would say it's not so important, or would you say also even more that it's a fundamental problem of the research domain, and we should all work hard to address that?
Highly learned opponent, thanks for the very interesting question. If I understood correctly, you want me to elaborate to the quality, how the quality of the sensor, especially the wearable sensors, influence the results. And how that what influence had it in my PhD studies. Indeed, as you say, there's many studies in this area that show, especially custom-made sensors, but also more commercial sensors. They are not as reliable as they are typically sold in the market. And this is something that a struggle that we faced at the beginning when we considered to use custom-made sensors such as Arduino or Raspberry Pi, and that need to be calibrated before they can be used. For this reason, we opted for commercial devices such as Fitbit or the Myo armband or the Kinect. We also use the Empatica sensor. We, let's say, bought in existing commercial devices that gave a certain level of reliability to the actual sensor readings. Still, we think there is indeed a lot of we typically say garbages in the data. So a lot of noise, a lot of difficulties of this that are kept into these sensor readings, and for this reason we try to limit to the types of sensor that we were most confident with. For example, Kinect is a depth camera that can track the body position, can estimate the body pose quite reliably, and we actually found out that even if different people are using the CPR Tutor, the same type of movement patterns are detected. So that also shows that the sensor is reacting in a similar way even with different subjects. I agree with your concern. This was not major limitation for the application that we had, because we had the application of CPR, which is a highly repetitive and highly structured and not so open-ended learning activity. But we can imagine that this will be a problem if the same system is used for different learning tasks, where there's a higher, we call it inter-subject variation. So there's much variation between the participants. So we think this is definitely one point that needs to be considered in future studies.
Okay, thank you very much. I have understood and appreciate the answer. In particular, you said that the not body-worn sensors are more reliable than the body-worn, yeah, like the Kinect. Let's come to one question. Yeah. So I was an ambulance man by myself. Yeah. So I did a lot of CPR in my active time, and so I would also not interested in the training of people. So by reacting on known issues within the training, which have been labeled by specialists, but also how people do that. Yeah. So I had a lot of anecdotes. I can tell you how many the kids can do in the situation. So my question is understanding human activities. Yeah? So by observation, and here I see clearly also the application of sensors is a big upcoming trend in research, for example, in the area of digital ethnography, yeah, so workplace ethnography, what people are really doing, and here we need to understand what humans are doing by automatic support. Yeah, so coming to human activity recognition, and you said you applied machine learning tools in your work. Would you already say that in multimodal learning analytics in general and in your work in particular, you did human activity recognition, or what would be needed to really to understand human activities from one person, from many persons, or even robots interacting with human? Yeah? So what are the conditions from the sensors and from the machine learning perspective?
Indeed, it's a very interesting point, the one about human activity recognition. I also mentioned in the thesis that it's going to be increasingly important and relevant for the autonomous agents, for robots, to understand and figure out what people are doing in front of them. And indeed, I think especially the CPR Tutor can be considered as a human activity recognition tool, because in one sense it has a system to recognize when a chest compression happens, and it can distinguish the chest compression from other types of movements. And so I think it's rudimental, but the first steps towards more holistic activity recognition. In a follow-up study I am doing at the moment, we are actually also detecting with smartphone sensors the mode of transportation, so how people are moving through the city, whether by bike or by bus or by car. So that's another example of activity recognition. And I think this methodology using sensors and machine learning, it's a very good approach to do this activity recognition. Definitely the collection of the data set, so collecting enough training sample is one main challenge. And for the CPR use case, that was relatively easy because the chest compression is a repetitive movement. For recognizing other activities and using supervised machine learning, we know it's going to be complex to collect enough data points to train the models But we think this is a useful, it's a sensible and usable approach to let machine better understand what people are doing.
Okay, thank you for your answer and thank you for your question, Professor Klammer. We are going to continue with Professor Hendricks from the Vrije Universiteit Amsterdam.
Thank you. Thanks for the invitation. I also read your work with great interest and pleasure. I think the work that you have been doing is very timely. It's really tackling problems that are now opportune and very important to look at, and how we can improve human-machine interaction in general. From that perspective, I was looking at the challenges that you addressed, and these challenges look quite generic. You identify 5 key challenges, but at some point in your thesis on page 65 you write that in many sectors actually IoT and sensor-based systems are common now and are being developed. At the Vrije Universiteit Amsterdam we are also looking at these issues. We're also developing a service-oriented architecture addressing social interaction between man and machine. Now the key question for me is, is there any domain-specific need from a learning point of view for such an architecture, and what your view on that is? Or could you also benefit more from all these other domains, perhaps?
Highly learned opponent. Thanks for the question. If I understand correctly, you want me to elaborate on how I can, in the future, use a service-oriented architecture, and in what kind of domains in learning I can use that, and if I can learn from other domains that are not strictly about learning. Am I correct? Mm-hmm. Okay. It is indeed, as I mentioned, now increasingly popular, and there are several initiatives in IoT data collection and creating an infrastructure that can gather and process and data coming from multiple devices in real time. So we are aware that there's many other initiatives in that sense, and we looked at these systems from what they can possibly do for learning, and we think that learning is different from other domains because it requires feedback, which in other areas such as the home-assisted living, or I'm thinking, for example, about the manufacturing or the transportations, all these other areas that also use IoT devices, they do not necessarily require always real-time feedback for the user, for the human. So we gave more emphasis in how actually exploit the data and how to create these feedback loops to the learner. And this, I mentioned, it can be valid primarily for psychomotor learning domains. I mentioned the sport example. I also mentioned learning how to cook a new recipe example. But we also have other examples in physical rehabilitation that where people have to relearn a certain ability that they have lost. And this is actually, it's actually very important to have real-time feedback systems. The real-time component, again, I stress it again, it's really relevant for the learner to be able to correct a certain behavior, to be able to suggest what to do in case a mistake happens. So I can imagine these types of multimodal tutor, they will eventually, in the near future, they will become more popular in different learning domains. And we we can see there are some examples on, for example, in the domain of sports, because for athletes it's important also to have some kind of feedback in how they are performing, how they're moving. I hope.
Okay, thanks for your answer. I guess there is still a lot to explore there also. And I would like to relate a little bit to previous questions which already discussed a little bit the cognitive type of feedback, and we also already heard about robots. And actually what we are working on is a math tutor robot that interacts with children to help them learn to subtract numbers from each other. So simple things at primary school like what is 23 minus 9? And this children make mistakes and then they need feedback. And we found this to be quite a challenge. And I was wondering, is your approach applicable also already in these domains? And if not yet, what would be needed in addition?
Indeed, personal robots that supports people how to learn. It is a vision that we mentioned in our thesis, and I'm pleased to know that you are also working in a similar project. And indeed, the domain of mathematics is, I would say, the most widespread in this area. In particular, learn with intelligent tutors. In my PhD trajectory, I've been also reading a lot on the field of AI in education and intelligent tutoring systems, which they are quite old communities. They have been developing cognitive tutors and intelligent tutors for more than 2 decades, and I can assert that the primary domain of application it's a cognitive domain, and with the special focus on subjects like mathematics and like physics. There are highly structured subjects in which there is a clear, correct answer, and you can easily capture whether someone is making a mistake. So most of the intelligent tutoring systems, Alex, for example, or other famous ones, they focus on learning mathematics, particularly for school kids, or learning physics or learning statistics. So that also where we wanted to our PhD project to stand aside or stand apart from the previous research, focusing on multimodal interfaces, so all the learning that happen beyond the computer desktop, beyond the keyboard and the mouse. And that's the reason why we chose to go into the psychomotor domain as compared to the more cognitive domain and as compared to mathematics and physics.
Okay, Professor Hendricks, is this enough for this moment?
Yes, that's okay, thanks.
Okay, then we will continue with the opposition with Professor Kaltz.
Okay, esteemed candidate, I'm putting my virtual hat on. Dear Daniele, thank you for giving me the opportunity to be on your committee. I was really impressed by your thesis. I enjoyed reading it because of the way it has been developed, but also because of the CPR topic. I found it really fascinating what you have produced in your thesis, and it's really timely, and I think it will make a lot of impact also in the community. I have prepared a challenging question for you, and it relates to your chapter 3, where you develop a taxonomy of multimodal data for learning. You provide a very good overview about sources for detection. And in chapter 6, you report about the system that detects performance errors in the multimodal data set. And in chapter 3, like also colleagues have already mentioned, you describe 5 challenges for multimodal data. So, and in recent times, there was a lot of discussion about what is called algorithmic fairness. And also in the light of structural violence, racism against minority groups and so on. How do you see this challenge for multimodal learning technologies? Do you see any specific bias arising from the multimodality dimension? Is it maybe even an extension of this bias? Is it a double, triple, an N bias, whatever? And what potential solutions do you see to avoid mainstream models that only work with a paradigmatic impression of a human being from a multimodal perspective?
Highly learned opponent. Thanks for the interesting point. If I understand correctly, you want me to elaborate on, especially on the algorithmic bias that can arise from using the multimodal learning analytics approach that I have been using. And I think indeed it's a very actual and relevant point to raise. And I have been also reading about fairness, about responsible AI, and also about the big, let's say, scandals that have happened in the field of AI concerning bias in facial recognition, for example, and racist or sexist algorithms and so on. And I think indeed there is an issue using machine learning, because machine learning, it basically finds generalization over the historical data. And whenever you make generalization, then you can actually incur in a certain bias or prejudice. I relate that to the CPR domain, for example. The CPR domain, the CPR Tutor, because it uses a Kinect camera, it sort of assumes that the body of the person doing CPR is actually fully functional. So it has 2 arms, 2 legs, and it has like a sort of a standard body shape. And that, even though it worked pretty well, the models generalizing across in different participants in our experiment, we think that it may fail whenever it encounters participants that does not match with the idea that the model built of the human body. And I was mentioning before the domain of physical rehabilitation and how to use a multimodal tutor to help people to retrain certain movements. And in that case, you clearly see that these types of technology that I assume that the human body is functioning in a certain way, they fail because the people that cannot do proper movements, they will not walk straight, they will not do the movements as the machines expect them to do. For this reason, I think there needs to be a balance between generalization and personalization. And we are making step forwards in that extent. So it is possible to, for example, learn individual model. So a machine learning model that generalizes over a single individual, admitted that it has enough data points. And so that it becomes a sort of a model of your previous past, and it probably will only, if it makes some bias, it will do that only on the way you were in before, and not using, let's say, data from other people. So perhaps balancing between generalization and personalization can be a way, but this is indeed the algorithmic fairness and how to use them, how to reduce the bias is actually a super big topic that not even the big tech companies like Microsoft and Google have fully resolved.
Esteemed candidates, thank you very much for this very good answer to my question. I have a very short one in addition. As I said, I was very happy to see you developing the CPR tutor. I was a little bit surprised that you focused only on the psychometric skills, because like also colleagues mentioned before, that might be only a small problem. One of the problems that I saw in the literature some years ago have more to do with learning transfer. So what do you do in the real situation? And the difference between the real situation and the training situation is quite big. And you have developed in your first chapter also some approaches, for example, to measure stress levels and so on. So do you have some ideas how you could, I don't know, use multimodal learning technologies to make the situation a little bit more like a real situation?
From the experience we had, it was very tricky to step into, let's say, the wild as a very first step. We realized that we needed to make very small steps to be able to create a system that implements a data-driven feedback loop and actually gives real-time feedback with multimodal sensor data. So you can see, the PhD thesis as sort of the first steps towards a system that is more holistic, that can take into account diverse settings, not only in the lab, not only training. Of course, the CPR domain, we were focusing on CPR training because the CPR, I hope that no one has to do real CPR to someone in cardiac arrest. Of course, that is meant for the training. But I think for other domains, learning domains, I'm thinking, for example, about sports, you can definitely think how to use that in the real field, for example, for a football player, or for a table tennis player on the real table while they're doing a match. So that can be, I think it can be done in the future.
Okay.
Thank you very much. I'm satisfied.
Okay, thank you. Then we continue with the questions of Dr. Bromuri.
Hello, Daniele, and thank you very much for inviting me to this very interesting defense. I think that your thesis is very to the point and very interesting in this particular period in which artificial intelligence is becoming, say, a threat towards the job of many people, and it's becoming very important to learn quickly and well. And I think next task. I have a question. So, I'm a technical person, so I have a technical question for you here, and it concerns chapter 6 and 7. Then the technical question also relates to a more system question. Since you use long short-term memories that can deal with sequences of data, have you considered adding an attention model to the neural network? At the moment, the feedback that you give is to us. Then I guess that the feedback that you give could be a bit more, let's say, elaborate. Okay. After you answer the first question, I will ask you the second one. Please continue. So, attention model.
Highly esteemed opponent, if I understand correctly, you want me to elaborate on possibility to exchange the long short-term memory network with attention models, or sequence-to-sequence models, also called. And I think this is indeed a possibility. And actually, the choice of the LSTM was to actually train a recurrent neural network. We haven't tried with other options. I think about convolutional neural network. But I'm aware of the fact that attention models are getting more and more powerful in especially learning a compact representation as a set of meaningful features that can be used later on for reducing the dimensionality, for example. And I'm actually thinking now, as a future follow-up work in my PhD, to how to create these attention models, sensor embeddings, I call them. So to actually derive from these large sensor data sets a smaller and more compact representation that I can later on use.
Okay, thank you. You can continue with your question.
Yeah. The second question for associated with this is, given that an attention model allows the neural network to focus on certain parts of the sequence, right, and state which parts are important, if you use this attention model in your current models, in your current multi-learning, in your current pipeline, you could give a feedback that is more complex than the current class. So you say use. Can you hear me?
There's a little technical.
Yes.
But you do understand the question?
Okay. Yes.
Yeah. So you say you have simple classes in there. You say use body weight, change position of the arm, etc., etc. Instead, you could say. Give a reason why they have to change the body weight. So I have a question for you, the following question, that is, what is the limit in terms of feedback that you can give to a before the feedback becomes obnoxious? So what is in your opinion the trade-off to be considered?
Yeah.
And what are the dimensions of the trade-off that one has to consider?
I think your question is super interesting. And indeed, this has not only to do with the choice of the machine learning model, but it has to do with how the human brain actually perceives the feedback, and has to do with cognitive load, has to do with the ability of someone to be able to capture a certain, especially in real time, to be able to understand a certain signal and to correct a certain aspect. In previous related research, we are aware that this quite complex, let's say, dashboards that provide many feedback signals at the same time, they end up failing because the person that is very focused on the task cannot focus on what to do, and loses somehow the importance, lose track of what is important to change. So we tried to actually stick to what is more natural. So we thought about how the actually human coach gives feedback. It would probably say, hey, you are not using your body weight correctly, so you should change it. It would probably also tell you, don't do it like this, do it in this other way. That also means that the coach has a better representation of the mistake, and also it knows exactly where to give feedback. This is of course, more complex than a binary classification task. It requires to have to learn different aspects of the mistake, and this is indeed something that needs to be investigated in the future. And I guess that your suggestion on using attention models that can focus on certain parts of the sensor signals, for example, it is one possibility, one way to go to be able to focus on what matters, and also, react on that. But what I think is very relevant is to understand the human perspective, not only the machine perspective, and to reflect on how to actually people can absorb, how can they digest the type of feedback they are given.
Okay, did you get the answer? There are
I'm very satisfied by the answer. Daniele, I have to say, bellissimo. So I don't have further questions to ask.
Then we continue the opposition with Professor Hoppe. You can start your second of your further questions. Your microphone.
Yeah. My mic.
Yes.
So we have a
that's
second
better.
round.
Yes.
I have one question that relates to your reference to ITS, and you also made that now in your answer, I think, to the second question of Kuhn Hendricks. And so ITS are an important reference point for you. And when you characterize ITS in your thesis, you see them very much as like an adaptive regulator in a system between the human individual learner and the system that helps the ITS, the learning support system. You have used the metaphor of instructor in the box, yeah? From the Paulson Solvay collection of papers. In the 90s, there was a big discussion about breaking up this instructor in the box model and opening up ITSs. And this is still on.
And
this is still
it's time.
ongoing.
It's time, Professor Hoppe. The beetle has given the sign for ora est. So we are curious further about the question, but you don't have to answer a question that is not given yet. So this is, I'd like to thank you for the answers. The Defense Committee will go back to the toga room and we will deliberate on your answers. And we see you back in a few minutes. Dear Daniele Di Mitri, the Doctorate Board, represented by the Defense Committee, has decided to award you the doctorate. Your supervisor has been authorized to confer this honor to you. Is aan. It is aan. So I give the Professor Trachtler to confer this honor to you.
By virtue of power invested in us by Dutch law, in accordance with the decision of the Doctoral Board, I conferred on you, Daniele Di Mitri, the title of doctor, and all the rights and all the duties to science and society associated by Dutch law or custom to a PhD degree at the Open University of the Netherlands. Do you promise to work in accordance with the principles of academic integrity at all times, to be careful and honest, critical and transparent, independent and impartial?
Yes, I do.
As proof of this PhD degree, I present you with a certificate signed by the Rector, Magnificus, Chair and Supervisors, along with a copy of your PhD thesis signed by all members of the Defense Committee presented here today. The certificate is presented there, and due to Corona regulations, you have to pick it up. I'm not allowed to give it to your hands.
So you can pick it up now.